Good day, everyone. Welcome to the Certified Math Majors channel. Now, in this video, we're going to talk about the rarely used formula in mathematics. Now, little do people know that this formula can also be used as a shortcut way, especially in dealing with coordinate geometry, wherein you're going to find the measure of figures plotted in the rectangular coordinate system. And of course, when you talk about areas, you're talking about the measures of segments. And once segments are in the rectangular coordinate system, you always find the length by using the distance formula. So when you do coordinate geometry, when you compute areas of figures plotted in the rectangular coordinate system, you have to expect that you will be using the distance formula at least once in every given figure. But this rarely used formula is actually a shortcut way on how to avoid using the distance formula when we find for the areas of figures that are plotted in the rectangular coordinate system. So the importance of this rarely used formula lies in the fact that the measurements and computations in coordinate geometry becomes less more tedious. And the formula that I'm talking about is the Pick's theorem. Now, the Pick's theorem gives us a ready formula to find the areas of figures that are plotted in the rectangular coordinate system. Now, according to the Pick's theorem, the area of any figure drawn in a unit grid is equals to A is equals to L over 2 plus I minus 1, where L is the number of lattice points on the perimeter of the figure, while I is the number of interior points inside the figure. Now, let's use the Pick's theorem in some examples. Now, the first example is you have this irregularly shaped polygon here that is plotted on a grid. So you can take this grid as a rectangular coordinate system. Now, we're going to find this area. Now, if you're going to use coordinate geometry, you need to plot all of these points. And since this is irregular, you need to subdivide this into basic shapes. And after doing that, you need to compute the areas by computing first some of the essential segments that are used to find the areas of the basic shapes that comprises this complex figure. And by that, we mean that we need to use several distance formulas in solving the area for this in coordinate geometry. But the Pick's theorem saves us from doing such long computations. So let's try to use the ready formula. You have A is equals to L over 2 plus I minus 1. Again, L is the lattice points. These are the points found on the perimeter. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I are the points inside the grid. So you have 1, 2, 3. We substitute that. That's 11 over 2 plus 3 minus 1. After doing basic computations, we come up with the area that is 15 over 2. Next example, this another figure here. Let's use the Pick's theorem to find the area. We have L over 2 plus I minus 1. You have 1, 2, 3, 4, 5, 6. There are 7 points on the perimeter. So that will be your L. Then the points inside, you have 6. So we substitute that. That's 7 over 2 plus 6 minus 1. The area will be 21 over 2. Now, just to show that the Pick's theorem is as accurate as the formulas for the areas of figures, we're going to find the area of this triangle plotted inside the rectangular coordinate system using the Pick's theorem. Now, if you assume that this is in the rectangular coordinate system, you have to take one of the vertices at 0, 0. So this could be 0, 0. Then this is 2 0, and then this is 1 1, this is 1 2, 1 3, 1 4. So using coordinate geometry, area is base times height. So the distance of this one, that will be the base. Distance of point B to point D, that's the height. Then you can compute for the area. Now, we avoid that using the Pick's theorem. L are the points on the perimeter. You have 1, 2, 3, 4. Interior points, you have 2. So we substitute that. 4 over 2 plus 2 minus 1. The area is equals to 3 units. Now, if we apply the formula, you notice that this here is the base is 2 units because you have 1, 2. It covers 2 grids, so that will be 2. Height is 1, 2, 3 because it covers 3 unit grids. Applying the formula, area is equals to base times height. The area of this triangle is 1/2 times the base is 2 times the height is 3. And computing that, we will come up with an area that is equals to 3 units. Now, in the same manner, if you're going to compute this using coordinate geometry by assigning ordered pairs to each of the points plotted here, then you will still come up with an area that is 3 units. And there is where the convenience lies in using the Pick's theorem. So that's it for this video. Please don't forget to like and subscribe to our channel for more math tricks. Thank you so much. Enjoy learning.